Okay, so 7.4. Okay, so again, we solved systems of equations by way of graphing, finding the point of intersection, etc. Your answer typically is going to be in a form of an ordered pair unless it's the same line or parallel lines. Okay? Yesterday, we did solving systems by substitution. Okay? Again, that is the preferred method. You won't go wrong going that direction. Today, we're going to do solving systems by elimination. Now, after talking to Allie, you will see elimination again. She said you're going to see it more than you would solving systems by graphing. Okay, she said you'll probably even see it in like science. Some of you that may be taking a lot of science courses in high school and everything. She said solving systems by substitution you should all have mastered before you go to Algebra 2. She said it'll make your life so much easier if you have solving systems by substitution mastered. She goes, graphing, have a good understanding of it. Elimination, have an understanding of it. But mastered, substitution. So if that kind of gives you an idea from someone that's already been through all the sciences and the maths in high school and in college, that's where your focus should be. So anyway, and like I even asked her last night, should we do the advanced? She goes, no. She goes, if they understand substitution, they don't need to worry about the other. You just have to understand how it works, which I think you guys are doing good. And by the way, all of my elimination notes, my big old black binder, gone. So last night I had to start from scratch and I wrote all new notes. Oh, wow. 4 pages to be exact of notes and problems last night to be prepared for today. Yes, teachers have homework too. Okay, so elimination method. I just like the name elimination. I guess it's my personality.
You like to eliminate.
I like to eliminate. Okay. Elimination method by adding or subtracting the equations or multiples of the equations you can eliminate one of the variables. Okay, I'll let y'all catch up. We're going to be playing around with this stuff to eliminate things so that we're going to eliminate one of the variables so that we can solve for the other one. Yesterday, we substituted variables in and out of equations to solve for each variable. Today, we're going to be doing eliminating. When you're done, put your pencil down so I know you're done taking notes. If you're doodling, I think you're still taking notes and we'll sit here forever. Okay, excellent. All right, and I'm going to teach by way of examples. Last night I was like, less words, more examples. And make sure and I'll have to keep saying this to this class, but make sure your examples are written, and I mean anything I write, you need to write, because I'm going to be writing words in the examples instead of writing them all up here. Does that make sense?
Yes, ma'am.
In other words, do what y'all usually do. Okay. 4x minus 2y equals 13. There's your first one, your first equation. And 8x plus 2y equals 23. All right. Write that down. Those are your two systems of equations. And again, we're looking for the ordered pair of where these two lines cross. Now, once you have it written down, I need your eyes up on the board. Taylor, you looking? You have those two written. Okay, so you need to be looking. All right, so the elimination game. We're looking to eliminate either the x or the y. We're looking to eliminate either the x or the y so we can solve for the other one. I want to draw your attention to this right here. Negative 2y and positive 2y. Would those eliminate? If we were to combine those, right? Like intruder alert, negative 2y and positive 2y is 0. So, I want you to write, can easily eliminate. So, be the investigator. Write down your two systems and then say, what can I do to eliminate them? Well, this one's kind of set up for you. You would wish all of them were like that. So, I'm going to go ahead and rewrite my two systems. And I'm going to kind of draw a line here, almost like an adding or subtracting problem. Taylor, stop playing with your drink and pay attention. Taylor's mom, he is playing with his drink. If he starts playing with his glasses, I will text you immediately. Okay, so now that I've drawn my line, we're going to use it like an adding or subtracting problem. There we go. We eliminated that. 4x and 8x is, everyone? 4x plus 8x is 12x. That's eliminated, so equals, what's 13 and 23?
36.
I should have written that right underneath there. That's going to be confusing. Okay, so I'm going to write this nice and neat. 12x equals 36. We've eliminated y, so now we're just left with the x. Now we do intruder alert. How do I solve for x, Michael? Divide both sides by 12. And I'm left with x equals 3. Oh, look, I have my first part of my ordered pair. Now we do the whole substitution method. I'm going to substitute this x as 3 into the x of either one of these equations. Now, me, personally, I almost always just use the first one. That's just my thing. But truly, you can use either equation. You could substitute it here, or you can substitute it here to solve for y. I'm going to choose the first one, me personally. So I'm going to rewrite the first equation. And I'm going to substitute this here 3 into the x. So then it's going to be 4 times 3 minus 2y equals 13. Are y'all with me so far? So 4 times 3 is what, Michael? 12. Very good. So I rewrite my problem. 12 minus 2y equals 13. All right, Cecilia, what do I do now? Cecilia, don't look at the floor. And quit distracting her. Now, don't throw stuff at her either. All right, Cecilia, what do I do now? How do I, what, girl? I got this on this side of the equal sign, 13 over here. I'm solving for y. What do I need to do?
Oh,
There you go. She got it.
yes. Did subtract 12.
Ah, there you go. We're going to be moving that 12 over there by subtracting. There, she's awake now. So I have negative 2y equals what?
Negative 12 plus 13.
Which is? Yes. Right? 13 minus 12, right? What do you get?
Wait, what?
What is 13 minus 12?
Oh,
1. Your brains are fried, obviously. So now what do I do, Cecilia? Yes, you're going to continue being my victim. How do I solve for y?
wait, what did you do?
Okay, let's back up. I substitute the 3. Yeah, because I know it's a mess. I substitute the 3, and I got 12 minus 2y equals 13, right? Right?
Mm-hmm.
Are you with me?
That's what.
Huh?
Mm-hmm.
Okay, now wait. I don't want to move forward till you get it. So I'm use this equation, right? Same one, correct? Okay, so I'm substituting this x into that x. You get that? Okay, so I've rewritten this equation with the 3 there. So now 4 times 3 is 12. But see, I have to rewrite my equation.
That's what I thought you did the first time.
Girl, all you did was move the 12 over, and then 10 years later you told me 13 minus 12 is 1. So now I'm asking.
I was confused and then
Okay, now I'm asking, how do we solve for just y at this point?
Intruder alert thing. That.
Yes, intruder alert thing. I'm dividing both sides by what?
-2.
There you go. Okay, so my y is -1/2, right? So there we go. We have our answer. 3 and -1/2. That's your answer. Now keep in mind, I'm going to write some notes here. You're going to write them too. You can sub that 3 in either equation to solve. Michaela, control your stuff, man. Okay, you can sub this 3 in either equation, meaning this one or this one, to be able to solve for y. I just chose the first one. Now, sit back, look at this. Do you have any questions? Yes, Aiden.
What happens if they're not like lined up? Like on this one's x and the y is lined up. What if it was like 2y minus 4x instead of 2y?
Oh, I got an example of that. You just rearrange it. You just rearrange it. I got an example for that. See, I'm one step ahead. Okay, any other questions about this, Taylor? I promise you better sit up. Okay? Taylor's mom, he is falling asleep in class.
No, I'm doing something on the paper. I was
Right. Are you drawing?
Yes.
There you go. Taylor's mom, he is drawing on his paper. Boy, you're on the other end of this room, and I still know what you're up to. Okay, yeah. I know what all y'all up to. See, I know what Cecilia's up to. Olivia, I'm on to her too. I'm just kidding, Olivia. She's new. I don't want to scare her. Okay. Let's move on to another example. Ooh, we got one down. Okay. Are we ready? Okay, so that one truly, if you think about it, wasn't that bad. It was already set up for you. They kind of gave you a bone. They made it easy. It was already set up. You saw it. We can eliminate it, solve for x, substitute it, and quickly, I use that term loosely, quickly found the y. Oh, yes, Michaela.
So even though you canceled out the negative 2y, whenever you rewrote it, you still wrote.
Yes, that's a good question. She said, even though we canceled that out, when we go back to sub, you're going back to the original equation. That's a good question. Yes, Whit?
We have eliminated the 4x and the
Oh, yes, I'm about to show you that too. Okay, so that was just, like I said, an easy. In fact, I even wrote easily. Because if it's already set up for you like this, trust me when I tell you, you want to go with what's the easiest, okay? This is set up for you. However, or before I move on, does anyone have any other questions? Okay, so this example was if it's already set up for you. I'm losing some of y'all, so we got to keep moving. What if they gave us 3x plus 2y equals 8 and 3x plus 5y equals 14? Okay, so unlike the last example we did, they didn't give us anything that's obvious to eliminate, okay? But you see right here, a 3x and a 3x. If you were to make one positive and one negative, can eliminate. So that says, hold on, make one positive, which one already is, and one negative, then you can eliminate. I'm going to show you how to do that. Yes, Taylor?
So in our notes for elimination method, it says by adding or subtracting the equations. Can you subtract the equations to get rid of
That's what I'm saying. That's what I'm about to show you.
Wow.
Yeah. Okay, but you have to do it the correct way. So let me show you. We're going to rewrite our two systems. I'm drawing my line. And Aiden did bring up a good question. You want to make sure your X's and your Y's are, in fact, on top of one another. They will try to trick you by switching these out. You just want to rearrange them to make sure they're on top of each other. Okay, so we're going to make one positive and one negative. I'm going to choose this one right here to be negative. But you have to apply the negative to everything in the parentheses for it to work. Do y'all understand what I'm doing here? So to be able to get these to eliminate, I got to make one equation, either this one or this one, all the opposite. So now I'm going to rewrite it. I have 3x plus 2y equals 8. Now this one becomes, y'all look, negative 3x. What does the positive y become? Negative 5y equals, and that positive 14 becomes negative 14. So it's all the opposite. Before I move on, does anyone have any questions as to what I just did? Okay, so what ends up happening is we can now eliminate the x. 3x minus 3x is nothing. So we can eliminate that. So 2y and negative 5y is what, Taylor?
Negative 3y.
Negative 3y equals, what's 8 and negative 14, Aiden?
The negative 24.
8, positive 8, and negative 14. I know. I'm noticing a bunch of farts in this class today. This is positive 8 and negative 14.
It's negative 6.
There you go. Negative 6. Does everyone see where I got that? Or where he got that? Okay. So now I'm just going to rewrite this down here for nice and neatness. Okay, so now, Michaela, what do I do? How do I solve for y?
Divide by negative 3.
Divide both sides by negative 3. Gabby, what do I get? Positive 2. Because a negative divided by negative is positive. Okay, so I have my y. Y is 2. Width. What do I do with the 2?
You're gonna substitute it in where the in
One of them, right?
in either one of them, either in the 2 or the 5 one.
Okay, so either one of these
Yes.
equations. So you're going to sub into either equation. Write that down. Sub that 2 into either equation. Okay, so which equation do you want to sub it in? The first or the second?
The first one.
Okay, he wants to choose the first one. I'm drawing a line because I'm going to rewrite that equation to be nice and neat. And we're going to substitute the y with this 2. So now I have 3x plus 2 times 2 equals 8. Do y'all see where we got that? 2 times 2 is 4, so I have 3x plus 4 equals 8. Michael, what do I do with the 4?
You subtract them on both sides.
3x equals 4. Taylor, what do I do?
You divide both sides by 3.
And so I get x equals 4 over 3. So my answer is 4 over 3 and 2. In parentheses and box. Remember, your x goes first and then your y. Any questions on that?
This isn't that bad.
Oh, that's the second example. Okay.
Can you make it?
Any questions so far? All right, let's do another. Y'all ready? 2x plus 3y equals 5. That's your first one. Second one is 4x minus 9y equals negative 10. Okay, So as you can see, are y'all looking up here? As you can see, do we have anything obviously in common here that we can quickly eliminate? We don't. But we've got to eliminate one of these. So you have choices. We could either work with the x's, and this is some of those questions y'all had. Could we have done one or the other? We could mess with the x's. We could multiply this whole equation by -2 to eliminate. Because then it'd be a -4. Do y'all see that? If we multiplied this whole equation by -2, this would then be -4. So then you could eliminate it. Do y'all see that? If we multiply this equation by -2, this right here would become -4. So -4x and +4x would eliminate. Or we could focus on the y's, eliminating the y's. We could multiply by +3 this whole equation to where this would be a +9, and then this would eliminate. You could do either one of those. So if you choose to eliminate the x, you would have to multiply this whole equation by -2 so that this would then become -4. Eliminate. If you want to eliminate the y, you would have to multiply this whole line by 3 so that this would be +9, that'd be -9, you can eliminate. So let's go ahead and do the first one. We're going to eliminate by multiplying by 2. So let's rewrite our equations, our systems. Once I start doing this, you'll see what I'm talking about. If some of you are still kind of on the fence, I can see your faces. So if we multiply by -2, I'm doing this, multiplying this whole thing by -2. Watch what I get. This is distributive property. You have to multiply everything in the parentheses by -2. I end up getting -4x. -2 times 3y is -6y. And -2 times +5 is -10. And then I'm just going to rewrite this equation here. And then I'm going to pause, let y'all catch up, sit back, tell me if you see it now. Okay. Does everyone see it kind of better now that I've performed it? Any questions before I move on? All right. So now that we've got something to eliminate, I can cross it out. So -6 and -9 is what, Taylor?
-15.
And Gabby, -10 and -10? There you go. So I'm rewriting because of neatness. So Cecilia, what do I do to solve for y? How do I solve for y? Huh? What about negative 15? Okay, both sides by negative 15. Good job. Okay, so what I have is, and a negative over negative becomes what? So what I have is y equals 20 over 15. Is that in lowest terms? Anyone? Gabby, what should this be? 4 over 3. Okay, so there's my y. 4 over 3. So now, Aiden, what do I do with my y?
You sub the y into one of the other columns.
Okay, you sub the y into either one of these equations. Which one do you want to choose?
So the first one.
He wants to choose the first one. So I'm going to rewrite the first one. 2x plus 3y equals 5. And we're going to substitute that 4 over 3 into the y. So I get 2x plus 3 times 4 over 3 equals 5. What is 3 times 4 over 3, Whit?
4. No,
Okay, tell me first what you get. 3 times 4 over 3 is
12 over 3.
12 over 3. We don't want to cut any corners just yet. That's right. So 3 times 4 over 3 is 12 over 3. 3 goes into 12 how many times? With 4. There you go. That's where he got his 4. Okay, Michaela, what do I do now?
Subtract 5.
What?
4.
There you go. Subtract 4 on both sides. I get 2x equals 1. Michael, what do I do now?
Yeah, right. 2 on both sides.
Divide 2 on both sides. So x equals a half. And then I'm done. So I have x is a half and y is 4 over 3. You don't have to change that 4 over 3. You can leave it the way it is. Any questions? Yes.
I'm still kind of confused on why you put the -2 on the
Right here?
yes ma'am.
Okay, so what I have to do is get this to here, to where I can eliminate it, right? How do I get this 2x to be negative 4x? I have to multiply it by -2. You see what I'm saying? No. So this is my original equation. We got to find something to eliminate, right? Okay, so if we choose to eliminate the x, I have to make these numbers the same, correct? Right?
Yes, ma'am. Yes, ma'am.
And then 1 has to be negative, right?
Yes, ma'am.
So to get the 2 to be the same as 4 but negative, I have to multiply it by -2. Are you just saying that? So I'll move on?
No, that makes sense.
Are you sure?
I'm positive.
So we could have done the same thing up here but with 3. We could have multiplied this whole line by 3. This would have been then 9y. And we could have subtracted or eliminated. Are you sure?
I'm positive.
Okay.
Get it? Positive.
I get, that's one of my kind of jokes. Anyone else have questions? I don't want to rush y'all through this. I need y'all to understand it. All right. Let's do another. Okay, the reason I'm taking my time on these is because before we move on to the next one, I have to make sure you understand what we did in that one. Because each example, if you notice, is taking it a step further. I'm about to take it a step further. Okay, here we go. Let's say they give us 2x plus 3y equals 6. And this is 3x minus 2y equals 8. Okay, sit back and look at this. First of all, they did not give you anything easy to eliminate. You can't, there's nothing you can do on just one row that'll help match up with the second row. There's nothing to do. So what do you think you're going to have to do? Taylor? Not just one, but both, right? We're going to have to adjust both lines to where we can eliminate. Yes, sir?
Couldn't we multiply the bottom line for y by 1/2? Sorry, 1 and 1/2.
So multiply this whole thing by 1.5.
So you can get 3y and -3y.
Or you could, but then you could be messing up these into some weird fraction things. Possibly. Well, maybe not. Or we could multiply both, like for example, I'm going to rewrite it for room. What if I multiplied this by 2 and this by 3 so that, look right here, this is negative, this is positive. If we multiply them each by something to get the same coefficient, then it's already positive, negative, it would work. So look, if we do this by 2, this would be positive 6, and multiply that by 3, that would be negative 6. We could then eliminate. Watch what I do. If you are confused, watch what I do. Again, yeah, okay. So we're going to multiply everything in the parentheses by out here. 2 times 2x is 4x. Distributive property. 2 times 3y is 6y. 2 times 6 is 12. Now we're going to go down here. 3 times 3x is 9x. 3 times negative 2, look, negative 6y. And 3 times 8 is 24. See what I did there? You can multiply both lines by something to get to a point where you can eliminate. We've now adjusted the first equation and second equation. You got to do the whole thing too. To where one of them, the y, went from a positive 3y and negative 2y to a positive 6y and negative 6y. Therefore, we can then eliminate. Make sure you have that down, and if you have questions before I move on, please ask. So you can do that. You can multiply both lines by something to get to where you want to be to eliminate. Now, 9 and 4 is 13x equals 36. 13x equals 36. Intruder alert, we're going to divide both sides by 13. X equals 36 over 13. All right, I got my X.
The other way works too. Let's try it.
Okay, good. Now, I'm about to throw you something. You ready? Instead of subbing, since that is an ugly fraction, you can do elimination again. And I added a smiley face.
You have to add the smiley
You have to add the smiley
Not
face.
that you're not taking your
No,
notes
you're
down.
not. If you do not put the smiley face, I cannot help you if you have questions, because then I know you're not taking notes.
Be serious about that.
So, this is an ugly fraction, yes?
Yes.
So, you could go and substitute it over here, and you'll get y. You'll get the same answer. But we've done that over and over and over again. You understand what to do there. But instead, let's try something different. And again, if you're like, no, Mrs. Rogers, I do not want to try anything new, that's fine. Go ahead and sub and have fun with that ugly fraction. Or we can do another elimination. Watch this. I'm going to rewrite. Does everyone have this down, by the way? Okay. I'm going to rewrite my equations. Now, this time, I want to eliminate, we eliminated the y to get x, correct? This time, I'm going to eliminate the x to get the y. So, I'm going to multiply the top by, again, our focus is going to be right here. I'm going to, Taylor, what would I multiply this top line by?
1.5.
No, don't listen to Taylor. Michael, what would I multiply? You're such a stinker sometimes.
Man. That's what I'm doing.
That's great. You do you. All right, I'm just going to tell y'all because y'all are making me mad. Okay, so I'm going to this time multiply the top line by -3 and the bottom line by +2 because we want to get these to where they can eliminate. So, by distributive property, -3 times +2x is -6x. -3 times 3y is -9y. -3 times 6 is -18. Again, we're doing distributive property. 2 times +3x is 6x. Oh, look, now I can start eliminating. 2 times -2 is -4y. And 2 times 8 is 16. So you could substitute, or you could just go back and do elimination on the other letter or variable. These two cancel out, and I'm left with -13y equals -2. I can then divide both sides by -13. Negative over negative is positive, and I get 2 over 13. Do not listen to him.
Well, I just said my method does work.
I know your method does.
But whenever you get confused with the fractions, it's
There we go. Any questions? None? Okay, did I fry your brains already?
yes.
No.
Gabby's saying no, Cecilia's saying yes, some of you are saying yes, some of you are saying no.
Some of us-
Okay, but here's the thing. I'm gonna pause. This is part one. Tomorrow we will do part two.